Hi, I'm Sai Krishna.
Hi, I'm Sujit.
Hi, I'm Surya.
Global Terrorism Analytics. Every 2000th death in the world is caused by terrorism. Terrorism is one of the biggest threats to humanity. It occurs unprecedented and in brutal mechanisms. These organizations have always had the upper hand in breaking defenses and choosing the right places to achieve their motives. To pull back this unfair advantage and keep the anti terrorist forces more vigile, we need a way to predict the attacks. Understanding a variety of past activities should provide a pattern which, in a way, would help us estimate the extent of possible attacks with respect to nature of attack, target types, weapons used, location, and agenda, among others. The database is sourced from unclassified media articles and contains information on multiple dimensions of each event. Putting all the information together, a generalization can be made as to what the important ingredients would be to predict the success of an attack given the strategic parameters. Predicting the success of a suspected event, is it meaningful? Intelligence agencies deal with a lot of suspected events and they are left with different kinds of possible scenarios. It's important to raise red flags at a given point of time when a particular scenario looks positive for an attack. This may not be an accurate result, but it's always worth to be future ready. The chi-square test is used to reduce dimensionality in the data. So, these features, after dimensionality reduction, will be used for random forests.
Let's go ahead predicting. Since our target variable is a binary variable, that its success is 1 and failure is 0. So we went ahead with logistic regression. But wait, we have a problem. That is class imbalance. We have around 20,000 data points which says it's failure cases, but we have around 1,60,000 data points which lies in the success case. To solve this problem, we use an algorithm called SMOT. It works by creating synthetic samples from the minor classes, that is no success, instead of creating copies. It does that by randomly choosing one of the k nearest neighbors and using it to create a similar but randomly tweaked new observation. These are the result after SMOT. Since our data has categorical variables, we had to do one-hot encoding on the data. But now we're left with a lot of columns. To eliminate feed columns, we use an algorithm called recursive feature elimination. It is based on the idea to repeatedly construct a model and choose either the best or worst performing feature, setting the feature aside and then repeating the process with the rest of the features. This process is applied until all the features in the dataset are exhausted. The goal of RFE is to select features by recursively considering smaller and smaller sets of features. After fitting the model and testing it on the test data, we got an accuracy of around 73%. Other metrics are also shown on the screen. Metrics like precision, recall, and F1 score are really important while solving these kind of problems. Now interpreting the ROC curve from the results. ROC is a probability curve and area under the curve represents the degree or measure of separability of the classes. It tells us how much the model is capable of distinguishing between two classes. Higher the AOC, better the model at predicting zeros and ones as ones. Logistic regression has few drawbacks. It cannot solve non-linear separable data efficiently.
Considering the shortcomings of the logistic regression model, we tried developing a prediction model using an ensemble learning technique called random forest. A random forest is basically a bagging of weak learners, which are decision trees. The decision trees used in a random forest are quite different from your normal decision tree, considering the fact that they select the root node based on completely different criteria. A decision tree chooses its root node based on metrics such as the Gini index and entropy, whereas a weak learner in a random forest selects its root node on a random basis, hence random forest. The class outputted by a random forest model is basically the majority class predicted by its weak learners. Hence, voting is actually used in a random forest model. We have modeled our random forest classifier using scikit-learn and have tuned parameters in order to get the best performance. The main reason why we've used random forest is because of its robustness to different data types such as categorical data, binary data, and numerical data. Considering our dataset, which has only binary and categorical data, random forest seemed like a very good option to use. Moreover, random forest does not go into the problem of overfitting the data, unlike a decision tree, which grows pretty long and faces problems of overfitting. Very less pre-processing needs to be done while modeling a random forest classifier. So after training a random forest classifier and performing a 10-4 cross-validation on it, we were able to achieve an accuracy score of 85%, which is pretty much better than our logistic regression model. So, given certain attributes about a particular terrorist attack, our model is actually able to predict whether it is going to be successful or not. We've also used time series analysis on our dataset. Our dataset consists of 47 years of attacks that have taken place globally. In order to develop the time series data which we can use, we actually grouped the dataset based on the year and assigned to it the number of successful attacks that have taken place. In order to modeling this data, we actually found out whether it was stationary or not, as seen by as we can see from the graphs, that the data has an upward trend, and after first order differencing, it kind of has a constant mean and also a sort of constant variance. We have plotted the PACF and ACF, and we found out that the model we used was an ARIMA model. The P and Q parameters were found out by performing a grid search using a metric of reducing the RMSE value. Finally, by dividing our 47 years of data into two parts, we were able to train the model on one part and also forecast for the remaining years. As you can see from the graph, the red line indicates the forecast made by our model and the blue line is the observed number of attacks. Clearly, our model is able to forecast almost the number of successful attacks that are going to take place in the futures to come.
So we have gone through how different models perform on the dataset while we are predicting the success of an event. It is important to note how different challenges were solved through the journey of this project. Different visualizations help us get meaningful insights and interpret the data well. The time series analysis can be used to validate the prediction of the models. That is, we can say how many attacks will be successful in a particular year and use that as a parameter to cross-check with the output of the predictor models.